So, okay, so let's get started. Let me do a quick roll call to see who all are here. We have Aradhya, Aditi, Anahita, Ashar, Rayans, then we have Nihit and Shyarli. So we have one new friend with us. What's your name, beta? With the name Naidu. I talked to daddy. Yes, beta? Samandita? Okay, can I request everybody to turn on the video so that I can make eye contact with you guys when I'm talking? So, Samandita, right? Good to see you, beta. Okay, so Samandita, Aradhya also please turn on your video. And Anahita, your video is not coming out. I'm not sure if it's some problem with the camera, but yeah. Okay, alright. So, for Samandita, one quick information for you, okay? So this is your first class. So just wanted to let you know that when I'm teaching things, I try putting focus on explain the concepts, okay? So you don't have to worry about taking notes or anything, okay? Everything that we are doing in the class, it is getting recorded. So me and the board is getting recorded, and you will have the video of the class later on that you can watch to revise if you forget anything, okay? So don't worry about taking notes. Focus on understanding whatever we are trying to learn as a concept. If something is not clear, ask me question as many times you want. But remember, we don't have to worry about taking notes. Yep. So on Saturdays, what we do is we check tables quickly first. So we check tables. So everybody in the class has memorized tables till 11, 12. Some of you have done till 8 or 9. So we'll do tables first, and then we'll talk about fractions, equivalent fractions and comparing fractions. Rudras, can you take your bag out? I want you to be as comfortable as you can. Okay? So let's check tables first. Is everybody ready?
Yes, sir.
Okay. So raise your hand, everybody. I will go to everybody one by one.
Yeah.
And once you are done, you will put your hand down so that I would know who all are remaining. Okay? So Rudras is the only child in the class, so I will start with Rudras. Hand down. Table till 6. 5 8
40.
6 9
45.
54. 6 9
69.
Yep. 4 8
32.
5 4
20.
6
26.
5 9
45.
Good job. So you have memorized tables, and I can clearly see that you are putting a lot of effort. That is visible, okay? So when you guys do something, I can clearly see without being right next to you, okay? Good job.
When you said 6, 9, I thought you said 9, 5.
That's okay. But yeah, I could see it. So good job. Let's go to. Shall we go with Samandita first? Samandita, you want to share all the tables that you know?
Yeah.
You know table till which number, beta?
12.
12, 8 8 jar. And keep your video on, beta, okay? Shanli, Rayans, everybody, keep your video on always. Yeah, yes, Anvita. I could not hear you. Say that again. 8 8 jar.
What did you say?
8 8 jar. 8 times 8.
You said 8 times 8?
Mm-hmm.
64.
5 times 8.
40.
6 times 9.
54.
9 9 jar.
81.
12 5 jar.
60.
11 8 jar.
88.
8 9 jar.
72.
So this is your first class, okay? And I'm very impressed, Samandita, okay? And I mean, because all of us, when we start the class, I mean, I don't see kids being asked to do tables here. So everybody starts from a certain number. But you're starting from 12. That's very impressive. I don't want you to go to 13 right now. Stay till 12 and maybe for next couple of weeks, okay? Make sure that when I say 12, 8 and 96, it should not take even a second. It should come like this. You are always accurate. I mean, today, based on whatever response you gave, you were accurate with your responses. I just want it to be more quick. 7 7 is 49. 8 7 is 56. It should come without thinking. Okay? If it starts happening, that this band will go to 13 also. Okay? Alright. Aditi. Aditi. Aditi, unmute yourself, but I cannot hear you. You are on mute right now. Aditi. Yep.
Is that me, sir?
Yeah, now I can hear you.
I can't hear your voice properly, sir.
Can you hear me now?
No.
Who all cannot hear me?
I can't hear you because your video's glitching. Yeah, your video's glitching.
Disconnect and join. Disconnect and join. Whoever is having problem in hearing me, disconnect and join. That's the best way to get the problem fixed. Oops, everybody. Can you hear me now, Asher? Can you hear me, Asher, now?
Actually not.
Shreyanji, can you hear me?
Your video's still yeah.
So, okay. Whenever you are facing problem, disconnect and join. That's the only way, okay? Shreyanji, let's start with Shreyanji then. Table till. Shreyanji, unmute.
Me?
Yep. Yeah.
12.
12. 8 8 ja.
64.
9 8 ja.
9 8. 72.
12 7 ja.
84.
11 9 ja.
99.
6 8 ja.
48.
2 7 ja.
40.
12 9 ja.
108.
Good job. Let's go to Anahita. Table till 12 8 8 ja. 9 9 ja. 7 5 ja.
35.
4 8 ja.
32.
12 9 ja.
100.
8 9 ja.
72.
8 7 ja.
56.
12 7 ja.
84.
Good job. Let's go to Asher. Asher, can you hear me okay now, beta? Yes. You guys have to roar. I want you guys to be louder than being, very feeble, okay? Okay, table till
11.
9 9 ja.
81.
11 7 ja.
77.
7 8 ja.
56.
9 7 ja.
97. 61.
63. 7 6 ja.
76 are 42.
8 8 ja.
88 are 64.
64.
Yeah.
Yep. Okay. Good job. Few misses here and there. Little bit of practice, no issues at all. Okay. Let's go to Rayans. Rayans in white. Rayans ready?
Yeah.
Table till
12.
8 8 ja.
4.
9 5 ja.
45.
4 9 ja.
36.
8 7 ja. 12 9 ja.
108.
Good job. Let's go to Rayans in black or blue. Yep. Rayans ready?
Yes.
Table till
12.
8 8 ja. 7 3 ja.
21.
9 8 ja. 12 7 ja.
84.
8 9 ja.
72.
12 5 ja.
60.
Good job. Aditi, ready? Can you hear me okay now, beta?
Yes, sir.
Okay. Table till
Uh,
12. 12 7 ja.
84.
9 5 ja.
45.
4 3 ja.
12.
12 9 ja.
108.
7 8 ja.
56.
2 9 ja.
18.
9 9 ja.
81.
11 7 ja.
77.
Good job. Let's see who all has not shared yet. Aradhya, ready, beta?
Yes.
Okay. Aradhya is very quiet. Little louder, beta. Okay. That will make it easy for us. Okay. I know you are very quiet, but that's fine. So table till
11.
okay 9 5 ja.
45.
4 8 ja.
32.
7 7 ja.
49.
9 8 ja.
72.
6 8 ja.
48.
8 8 ja.
64.
9 9 ja.
81.
Good job. So, you know what? Among all of you, there are few kids whom I have met in person, and Aradhya is one of them. I bumped into Aradhya in Patel Brothers once. I'm looking forward to meeting all of you one day somewhere. Okay? I don't know where. Some of you who come to the classroom, obviously I'm meeting you in the class, but everybody else, I'm sure that we'll meet somewhere, maybe in a mall, maybe in a store, maybe in a medical store, wherever. We'll see. Alright, so who has still not shared? Nihit. Nihit is quietly waiting for his turn. Nihit, ready?
Yes.
Table till
8.
8 5 ja.
14.
4 9 ja.
45.
4 9 ja.
36.
6 5 ja.
30.
7 7 ja.
49.
6 8 ja. 6 8 ja. 48. Yep. 8 3 ja.
44.
8 10 ja.
80.
Good job. So a little bit of misses here and there. Keep practicing. You're not going to 9. You're not going to 10. Let's make sure that till 8 there is zero problem and there is zero wait time. Alright? Is everybody ready to start learning something? Okay, start singing. This is not a singing class. And this is not a dancing class either. Nobody will dance or sing. We'll do only math for next 45 minutes. Yep. Now, we are going to talk about equivalent fractions or comparing fractions. Okay, that is our focus for today. Now, what do you mean by equivalent fraction? We talked about that in the previous class. Can anybody explain me one more time? Okay, that's fine. What do we mean by equivalent fraction? Yes, Aditi. I'll come to your answer.
Two fractions are the same, or if they have the same value, but their fraction is different, they're still equal.
Okay. Yeah, Asher, what is your response to that?
Fractions are fractions that's denominators are the same, Is it the denominator or the...
Okay, let's see what both the Riyans have to say. Riyans in white and black both. One by one. Riyans in white, you can start.
The fractions that are the same but with like a different number of numerator and denominator.
Blue Riyans or black Riyans.
Fractions are two fractions in different numbers but cut in the same portion.
Anahita, what is your definition of this? Anahita, you'll have to be a little louder for me, beta, okay? I could not hear you actually.
Equivalent fractions are fractions with the same value.
Very nice. Anybody else? Let's see what Samanvita has to say. What is your understanding, beta, of an equivalent fraction? Have you heard about it before?
Yeah.
What is your understanding? I mean, just share what you know. Right or wrong, we'll not care about it.
They have like different numbers.
They could be different numbers. Okay? Shyanvi, one last response. Yeah, go ahead.
So equivalent fractions are, so if you have like two number lines and you would prove that fraction on the number line, it would have like the same value.
Right. So basically, if I look at everything that I heard from you, right, I can put that in one line. Some of you gave me exact same definition of an equivalent fraction. Equivalent fractions are the fractions which have same value. Now let's look at two examples. 1 by 2 and 2 by 4. So they look to be different. 3 by 6. They all look to be different, but they are actually having the same value. So 1 by 2 is half or 0.5. This is a 2 by 4 is also half or 0.5 if you convert that to decimal. 3 by 6 is also half or 0.5 if you convert that to decimal. So the value of each of these fractions are the same. That's why they are called equivalent fraction. They are not called equal, they are called equivalent. The reason being they look different. 1 by 2 looks different from 2 by 4, looks different from 3 by 6, looks different from 1 million by 2 million. That's why they are not told equal, they are told equivalent. Just to keep any confusion away. Is that okay? So anybody saying or talking about equivalent fraction, the simple one-liner would be they can have same or different numerators or denominators, but their value will be the same. The absolute value of a fraction would be the same. When I say absolute value, like what you said, they are all half. I can represent half as 0.5 in decimal, and that is called equivalent fraction. Yep. Now if I have a fraction, can I create equivalent fraction out of it? If I have, let's say, 2 by 9 as one fraction. If somebody says, can you create 4 equivalent fractions of 2 by 9? How will you do it?
No, it's not possible.
Don't jump to a conclusion. Think about it. Where is your notebook and pen? We are talking in air. I am teaching math and Rudrash is listening to me in style and giving me answers. Take a notebook out. Yes, Aditi. Yaditi.
Okay, you can't do it.
I am saying I have a fraction 2 by 9. Can you create 4 equivalent fraction of 2 by 9?
Okay, I'm still working on that.
Okay, that's okay. Let's see, anybody having any response? Anahita, Samanvita, both the Riyans, Shyanvi, Nihit, Aradhya. See, the question is very simple. I have a fraction. I'm asking you guys to create 4 or 6 or 10 equivalent fraction of this. How you can do it? And if you ask me that, okay, if I have a fraction, how many equivalent fraction I can create? I will say millions, infinite number of equivalent fraction. How? How? You said you cannot create. I'm saying I can create millions of equivalent fraction. Let's look at it. I have 2 by 9. What will I do? I will multiply and divide by 2. Meaning I'll multiply the numerator by 2 and multiply the denominator also by 2. What do I get? 4 by 18. This is one equivalent fraction. Oh, 2, I don't like 2. I can multiply by 7. I am multiplying the numerator and denominator by the same number. And I can choose the number of my choice. I can choose 7, I can choose 8, I can choose 25, I can choose 1 million, I can choose 1 billion, I can choose a Google. The numerator and denominator I can multiply. Yeah? And Google is a number, okay? So Google as a company has derived a number which is a much bigger number, right? Like we know about million, billion, trillion, gazillion. Google is a number after that. Okay? So anyway, so here, what I'm saying is if you have any fraction, you can create as many equivalent fractions by multiplying the numerator and denominator by the same number, okay? You can multiply by 2, you can multiply by 3, by 4, by 7, 8, 9, 10 and you can just go on. So, simple answer to what I was asking was, if I have a number, if I have a fraction, how many equivalent fraction I can create? As many I want. As much, depending on how much time I have. You say, okay, can you create 5 million equivalent fractions? I will say, yes, I can. Give me 10 days, because it takes me at least 10 days to write that many numbers.
Oh, yes.
Yeah? But is that part clear to everybody? Aditi, clear beta? Clear? Rayans?
Yes, sir.
Samanvita? Shanli? Nihit? So here's the thing. When I was asking you guys, can we create an equivalent fraction? First thing that should be that, okay, stop playing with emojis, stop playing with emojis. Otherwise I will also stop playing. And then you will see the balloons flying. No, here the balloon doesn't fly. This is not an Apple device. It doesn't fly. Wonderful. Okay, so coming back to what I was saying was, if you have a fraction and somebody says, find out the equivalent fraction of this, you can say, okay, I can find anything. Any number of equivalent fraction. I will just choose a number of my choice and multiply the numerator and denominator by the same number. And I can just go on. And you know what? Here, when we are multiplying and dividing by this, or multiplying the numerator and denominator by the same number, what we are doing, we are not changing the value. Because you can anytime you can do tic-tac-toe. Your value is still the same. Correct?
Oh, I get it.
Is everybody with me?
Yes, sir.
Okay.
Sir.
Now let me make your life a little more interesting.
Yay.
Yay, we'll do dance and song. Okay. Now, if I say 3 by 8 and 4 by 9, which one is bigger? Okay. Anybody on the screen? I'm saying between 3 by 8 and 4 by 9, which one is bigger? This is about comparing fractions. So, I'm saying which one is bigger? Which one is a bigger value? If I say I'll give you 3 by $8 versus 4 by $9, which one is bigger? Yes or sir? Tell me.
It is equal on answer.
I'm sorry?
It's equal on answer.
A little louder, I cannot hear you.
It's equal on answer.
Could be, but if you think they are both equal,
I think it's
I'm sorry?
4-9.
4 9. Let's see what Aditi has to say. Yeah, Aditi. Anahita,
4 9s.
Shanvi,
4 9s.
Riyans. I'll come to you. Riyans, which one?
4 9s.
I actually, my answer, I changed it. It's 3 by 8.
Okay. Nihit.
4 9s.
Now, I am a very, very bad teacher. I'm saying why. Now prove me why 4 by 9 is bigger. How will you think about it?
I changed it because if you put the
But you
3
use a
by
number line.
You can use a number line.
but
Yep, okay. No, so math is not in air. I'm saying how 4 by 9 is bigger because this is 4 by... No, you cannot keep drawing in air. That gets very confusing for me. Okay, let's see what Aditi has to say. Yeah, Aditi.
I did the butterfly fraction technique.
I'm sorry?
I did the butterfly fraction technique, which means, for example, 38 and 4 9s, you have to multiply 38 times 9 is 27 and 3 8s, 8 times 4 32, with 4 9s. So they have to tell 27 32, which one's bigger. So 32 is bigger, so that makes 4 9s is bigger.
Let's see what Anahita has to say. Yeah, Anahita.
That's also what I did.
That's also you did. So it's a butterfly method, what you did. Now, be it a butterfly, be it a cockroach. For me, it's very simple. I mean, again, I'm not denying what you guys did, and actually you did it right. So here, yes, Riyans.
4 over 9 is correct because the method I used was to give them the same denominator and the rest was left.
I love that. So actually what Aditi explained, what Nahita explained and what Riyans is saying, that is, I'm combining them together. Now, Aditi and Anahita said that we used butterfly method, meaning I had 8 here and 9 here. 8 went here, 9 went here, meaning 9 got multiplied with the numerator denominator here, 8 got multiplied with the numerator denominator here. Now what Riyans added to it, Riyans kind of added spice to it, saying why we did butterfly method, because now you look at this, you have, our question was 3 by 8 and 4 by 9. Our goal is to make the denominator same. So if somebody says 3 by 8 versus, let's say, if I just make it up, okay? Somebody says 11 by 17 and 15 by 17. Which one is bigger? It's very easy peasy. You see the denominator is same. You will say, okay, 15 is a bigger number, so this is bigger. Correct? So your first goal is to make the denominator same. That's why I was saying you need notebook and pencil, because that is where your brain and action comes together. Okay? Now, here, same thing we are trying to do. If we get the denominator same, then it's very easy to make a decision. Now let's look at it. This became 9 3 are 27, by 9 it is 22. And this became 4 is 32, divided by 72. So it's very easy, right? You see 32 by 72 versus 27 by 72. Which one is bigger? 32 is bigger because my numerator is bigger. And this is equal to this one. So now you can say this is bigger. So you guys already knew this. We are just putting a structure to it together, right? Did I teach anything? No, I did not. I collected information from everybody and I put this on the board. So you guys already knew about this. See how smart I am doing. Smartly I am doing it. I am not teaching anything myself. I am collecting information from you all and then giving it back to you guys. But that was the lighter part of it. The serious note here for you all is this is other thing that you can always look at to make your learning more interesting and fun. When you talk to your friends, when you learn something, share with them. When you don't know something, ask them. And there'll be one friend who would know about it. That makes your learning much quicker and faster. See, it's always better to learn things from people of your age than learning from an old man like me. I mean, I'm not saying that I'm not going to teach. I will continue teaching. What I'm saying is, you also learn a lot of things from your friends. And so here, when it comes to talking about comparing fraction, this is one of the methods. So let's say, so there are two things that we learn. We learn about how do you find equivalent fraction, and then we learn about how do you compare fractions. So when it comes to finding an equivalent fraction, what we learned was, if I have a fraction like this, I can choose any number. I can multiply and the numerator denominator by 2, I can multiply the numerator denominator by 7, I can multiply numerator denominator by 59, whichever number I like. I just make sure that I'm multiplying the numerator denominator by the same number. It will be a crime if you do this 8 by 6. Now you have changed the overall value. This is not equivalent fraction. Because your numerator and denominator are different. So you're not talking about the equivalent fraction anymore. This is not equivalent to any of this. This is a mistake. So when you are trying to find out an equivalent fraction, you have to make sure that your numerator and denominator are same. That is the only thing that you have to be careful about. Does it make sense?
Yes, sir.
Everybody on the screen? Ashar, Anahita, Samanvita, both the Riyaz, Nikhil, and not Nikhil, Nehit. Yep. Everybody okay? Shanli? Now,
Yes, sir.
so this is one thing. We learn how do we find the equivalent fraction, and then we use that concept. Stop playing with emojis, Nehit. We'll play with math, not with emojis, okay? Now we are using the same concept of equivalent fraction to find out when, let's say, this is what we were doing. That okay, 3 by 7 and 4 by 8, or 3 by 8, 4 by 9, whatever it was. We were trying to find out what did we do. Actually, if you see, when we are talking about the butterfly method, when we are talking about butterfly method, what are we doing actually? We are trying to find, so we did, okay, butterfly method, meaning I will bring 9 here and bring 8 here. What are you doing here? When you are trying to find out the equivalent fraction, you have the option of choosing whichever number you want to choose. This butterfly method tells you how do you choose the right number to be able to compare, isn't it? So, see, this was an actual fraction. You found a number that you want to multiply it with using the butterfly method, but this is eventually this is an equivalent fraction of 3 by 8. Yes, Aditi.
The board is shining, so I can't see it.
There is one place in the board where it shines. You have to tell me which number is it signing here, here, or here. 1, 2, and 3. Which one is signing? 1 or 2 or 3?
2.
2. Everybody 2? Yeah, okay. So 2 is signing. What I will do is I will not use this part of the board. All the writing I will do will be here or here. Is that okay for everybody? Okay.
Yes, sir.
Now I have to keep the light on. The reason being it's hot outside, so I have turned on the AC here, so that's why I have closed the door. So I have to have the light on. Now, so what I was saying was, equivalent fraction we know or we learn. How do we find equivalent fraction? And we use the method of equivalent fraction to find out we use that method to compare two fraction. If somebody says 1 by 7 or 2 by 13, which one is bigger? I will say, okay, fine. We'll use the butterfly method, and we know that I can multiply here and here 13 and here 7. And when I'm doing that, I'm anyways not changing the value. I'm just finding out the equivalent fraction. So I'm not hurting the value of the fractions. I'll just get an equivalent value, and the 13 7 is 91. 91, and this is 13. Now this is 2 7 14 by 91. Now we know which one is bigger. So we use the butterfly method, equivalent fraction and the equal denominator idea to compare the fractions. Is that okay?
Yes, sir.
Now, Sivakeswa, you joined a little late. So I'm just quickly checking with you. Are you able to follow what we are discussing right now? So basically, so what happens, Sivakeswa? You have stopped coming to the classroom? See, Rudraj is alone in the classroom. He is waiting for you. He is crying also.
It's not last. I'm not last class. I'm traveling tomorrow.
Okay.
So I'll be back by August or July.
Okay. Alright, so anyways, so coming back to this one. So what I'm saying was that this is how we compare fractions. Now, or what do we mean by equivalent fraction? Meaning there are two fractions which have same value. Now there is another way of finding out the actual value of a fraction. And that I call as chicken and egg method. Who all remembers the chicken and egg method?
Oh yeah, I remember it's used for division.
Sriyanvi remembers. Snehat, how about you? You remember chicken and egg? Ashar, you also remember chicken and egg? Riyans also remembers, Sivakeswa remembers. Okay. So the chicken and egg, we'll anyway do a quick revision, will not take much time. So, and it has nothing to do with who likes chicken or who doesn't like chicken. It's just a concept, okay? Chicken and egg. So we are not trying to go into the complex part of it. Now coming back to chicken and egg, what do I mean by this? If I say 1 by 2, it is equal to 0.5. 1 by 3, it is equal to 0.3333. 1 by 4 is equal to 0.25. 4 by 9 is equal to 0.444. Do you think I have memorized it?
No.
No. I have not memorized it. I am calculating right now. How do you convert a fraction to a decimal? That is where we use the chicken egg method. Aditi, do you want to tell a few lines about it before I get going? I want to see how do you guys tell your stories. Yeah, Aditi, go ahead.
Like the butterfly method, one of my math teacher, Miss Hodge, taught that butterfly method, and I got smarter and smarter on this. So I did it all along. This fraction, all this, the number lines, and all this. That's why I think the butterfly method is very easier.
Okay. Let's see what Asha has to say. Yeah, Asha, tell me your story. Tell us your story.
Hold on, I forgot to put that in.
Okay, that's okay. So now, for Samannita and Anahita who have not heard this story before, and some of you who probably have forgotten a part of it, let's come back to this. I'm saying 1 by 4, or let's say 1 by 2, let's start with the easy one, equal to 0.5. And 2 by 4 is also equal to 0.5. And that is why they are equivalent fraction, because their actual value is same. I am saying, how do we find it out? 1 by 2 equal to 0.5. Okay, let me not worry about it. It simply means 1 by 2 or 1 divided by 2. So I have to divide 1 by 2. Yep. Up to this much okay? I am trying to see this 1 by 2. I am trying to find out the value of that. And 1 by 2 simply means 1 divided by 2. I'm trying to divide 1 by 2. Yeah? Yes, listen, Anahita.
I've done this method before, but I don't remember it.
Okay. So, one thumb rule. Nihit, stop playing with emojis, beta. Emojis get me distracted. Okay, here. One thumb rule or one line of statement, okay? Or one statement. There is nothing called one line of statement. One statement that you have to remember is decimal is a chicken that lays one egg at a time. Decimal is a chicken that lays one egg at a time. Now let's see how that statement works for us. One egg. Egg looks like a 0, right? Somewhat. So that's what we'll do. I'm trying to divide 1 by 2. So I'm trying to find out the nearest number that comes in the table of 2, which is close to 1. 1 is smaller than 2, I can do nothing. I have to make this one bigger. I have to make this one bigger to be able to divide by 2. So, I call chicken. Decimal is a chicken that lays one egg at a time. I recall chicken. Put a decimal here. It lays one egg at a time. It laid one egg for me. Now I have a 10. No memory, no background noise. As soon as I put decimal, which is a chicken that is laying one egg at a time, it laid one egg for us. Now this became 10. 10 is bigger than 2. How many times of 2 will get me a 10 or a number closer to 10? 5. 2 5 are 10. Are we done? Yeah?
Yeah.
We got 0.5. Now going back to the same point. Whenever we needed eggs, we had to have a chicken. And decimal is our chicken which lays one egg at a time. I put a decimal, it laid one egg for us. And why I'm saying one egg at a time, I'll show you guys now. Now, if I say 1 by 8 is how much? I will say 0.125. Not because I've memorized it. I've come across this. Here it says 1 by 8, meaning I have to divide 1 by 8. Okay? So let's do the simple calculation. 1 divide 1 by 8. Now again, 8 is bigger than 1. I cannot do anything. Whom do I call? Chicken. What is my chicken? Decimal is my chicken. What does it do? It lays one egg at a time. See, now I have a 10 which is bigger than 8. How far I can go? 8 1 ja 8. That's it. 8 2 ja 16 is bigger than this. So I will say 8 1 ja 8. What is the remainder? 10 minus 2, 8. Sorry, 10 minus 8, 2. This is my remainder. Now again, 2 is smaller than 8. But I have a chicken that lays one egg at a time. And there is no limit. Chicken can just go on laying one egg at a time. Infinite number of times. Till you want. So here you have come at the same situation where you have a number smaller than 8. But you have a chicken that will lay one more egg. And you can continue. Now you still have 20. Now 8 1 ja 8, 8 2 ja 16, 8 3 ja 24. So I can go up to 16. 8 2 ja 16. What is remaining? 4. Again 4 is smaller than 8. Don't worry. Chicken is laying one egg at a time. It laid one more egg. Now 8 1 ja 8, 8 2 ja 16, 8 3 ja 24, 8 4 ja 32, 8 5 ja 40. Oh, 8 5 ja 40. Done. We don't need the services of chicken anymore. We are done. Yeah? Anahita, Samanvita, Sivakesava, Nehet, Riyans. Is this chicken looking interesting? Anahita, how was it, beta? Different experience with chicken? Okay. Samanvita, did you like chicken? No, and again, don't have to worry. Where did Samanita go? She got dropped off? Okay. So again, it has nothing to do with our food habits, okay? We all eat what we like. So if somebody doesn't like chicken or somebody has issue eating chicken, let's not worry about it. We are not trying to get to the discussion of eating chicken or not eating chicken. We are saying how chicken can be helpful to us. Yes, Anaita?
I'm vegetarian.
I'm sorry?
I'm vegetarian.
Your friend is here?
No, I'm vegetarian.
You are vegetarian. So let's not worry about it. So I'm saying we have nothing to do with the food habits. It's just about, see, like we know about animals, I'm saying I have given it a story because story sticks longer with us. So I have given a story. Nehal, don't play with that. What I'm saying is, this story is that chicken lays one egg at a time, and we'll use that understanding for solving or converting a fraction to a decimal. So the question to Samanvita, were you able to follow it? Was this a good concept or not really?
It's good.
Yep, you were able to follow, right?
Yeah.
Okay, cool. So we still have 10 more minutes. So
2 more minutes?
2 more minutes. I said 10 more minutes. Shh, that's a waste of time. Let's not go to. So what did we learn today is we learned how do we convert a fraction to a decimal. Now, if somebody says 2 by 8 and 8 by 32 are equivalent fractions, we know how do we check that. We can check that, and we can also say, okay, fine, this other method I can do. Let me find out the value of 2 by 8. 2 by 8 is 0.25 and 8 by 32 is also 0.25. So both have the same value. That is how they are equivalent fraction, and we know how do we convert a fraction to a decimal now. Yeah?
Yes, sir.
So, yes. Somebody saying something? So now, for you guys, when I made that statement that chicken, decimal is a chicken that lays one egg at a time and there is no limit to it. Let me show you the power of that. If I say 1 by 3, okay? We are trying to find out the value of 1 by 3, meaning we are trying to convert this into a decimal. Or we are saying, I want to divide 1 by 3. Let's see what happens. So we are trying to divide 1 by 3. Again, same thing. See, 1 is smaller than 3. I need some help. And who comes to help us? A chicken. A decimal. That lays 1 egg at a time. It laid 1 egg. Now I have 10, which is bigger than 3. So I can start. 3 times 3 is 9. What do I have now? 1 again. Again 1 is smaller than this, but I have a chicken which keeps laying 1 egg at a time. 3 3s are 9. What do I have? 1. I have a chicken that lays 1 egg. 3 3s are 9. Again 1 is smaller than 3. I have a chicken which lays 1 egg. I am not putting decimal 1 by 1. I am putting only 1 decimal. And that keeps on laying 1 egg at a time.
We'll go forever.
So, see, this chicken is not ready to stop. Chicken is ready to provide its services till you need it. Till you are not done, it will keep on laying 1 egg at a time. And you can keep going as far as you want to go.
Wow.
So that is why I made that statement. That this is one chicken that doesn't stop laying eggs. It lays 1 egg at a time. And a time means 1 step in the division part. Okay? Does that make sense to everybody?
Yes, sir.
Is this a worthy chicken whom we can rely on for converting fraction to decimals?
Yes.
Yep. And now if you guys relate, yes, somebody saying something. Yeah, Aditi. Okay. So, what are the things that we did today? We talked about what is a fraction, what do we mean by equivalent fraction, how many equivalent fractions we can derive, how do we compare different fractions, and then we looked at how do we convert a fraction into a decimal. Yes, Ashar, you had raised hand.
We did fractions with chicken.
Equivalent fraction with chicken egg. Yeah, you can always do that, right? So let's say if you have to find out 1 by 9 and 2 by 17. If you have to find out which one is bigger. So one thing you can do is, like what Anahita and Aditi were saying, you can use butterfly method to make the denominator same, and like Riyan also explained, you can make the denominator same using the butterfly method, or you can convert this to decimal and you can convert this to decimal. Let's say this gives you 0.11 and this gives you 0.13. Now once you get the decimals, oh, this is 0.13 and this is 0.11, this is bigger. Done deal. Yeah? Does it make sense, everybody?
Yes, sir.
Shivakesava, Rayans in white. Rayans in white has been quiet. What happened? Everybody with me so far?
Yes, sir.
Nihit, show me your latest glasses. Where did Nihit go? Okay. Now these are not glasses, these are emojis. I wanted to see you with your funky looking glasses. Okay. Alright. So anyways, that's the lighter side of it. So that's a recap. Tomorrow what we are going to do is we will pick up the next topic, and there is nothing for us to practice with respect to equivalent fraction or comparing fractions or converting fractions to decimals. One thing we will do is we learn how to convert fraction to decimal. If somebody says convert decimal to fraction, do you guys know? Remember how to do it? We'll learn that in the class tomorrow. Rudraksh, okay, no, wait.